look at why you would want to use Etoys, what's special about it for modeling and simulation. And by the way, if you've got this presentation on your computer, you can follow along and you can actually do some of the things I do, so you can get a little practice. First of all, Etoys is free and open source. That's very important in an educational environment where you don't have a lot of money to buy software. Open source means students can actually go in and change the background. Etoys is written in Smalltalk and it runs in an environment called Squeak. Students can actually go in and change Squeak and change Etoys if they want, if they get that advanced. That's an advantage, I think. I prefer open source software. It runs on many different platforms, certainly the Mac and the PC and Linux. And it runs bit identically, which means it looks the same on the PC as it does on the Mac. So you don't have the problems of some software that run a little differently on different platforms. It has extreme late binding, and what that means is that this is an interpreted language, and it means when a student makes a change, it takes effect immediately. They don't have to, it's certainly not a compiled program where you have to compile it and then go look at it later. If you make a change in the program, it happens immediately. I'll show you that in a moment with this little program that's running on the left. Even this little icon of the mouse is active. It uses tiles for programming instead. They're graphical tiles, and these are graphical tiles right here. Start forward by 50. That's much more self-evident than some kind of command line program. In fact, I'll show you what this command line program looks like. In Smalltalk, this is what it looks like. And the problem with this is, especially for younger children, this is designed for 10-year-olds, if you don't have the colon here and the period here, and if you don't end this without a period and so on, the program won't run. And that can be very frustrating if you have hundreds of lines to try to debug it. Whereas when you're using the tiles, it's fairly self-evident and you can't make those kind of software errors. However, more advanced students can write programs in Smalltalk because there's more in Smalltalk than there is in Etoys. And if they want to do something that isn't in Etoys, they can learn Smalltalk. And so there's a way to advance. It's multimedia, certainly. It has all the kinds of things you'd want to use, especially to create simulations. It really keeps the mind active. Alan Kay, who created this, described it as hard play. You're playing, you're exploring, but it is a lot of work. You are using your mind. And it's revolutionary, I think. It's very different from anything you've seen. For example, let me stop this program, grab this star, and if I hold down, now if you have PCs, you hold down the Alt key. If you have a Mac, you hold down the Command key, and you click on the object, in this case the star, and instead of having a menu, Squeak and Etoys has what's called this halo of options. This allows you to duplicate. This allows you to move. This allows you to move the object to trash and so on. So it's very different. There isn't a menu. It does not look like Microsoft at all. But it's a revolutionary way of looking at things because everything on this screen is an object. It's an object-oriented programming language developed in the 70s. The only reason it didn't take over is because it was too big to run on the computers then. And now it's easy to run on computers because computers are so much more powerful. So it's revolutionary in the fact that everything on this page is an object, and the objects can communicate to each other, and you can do very creative things with Etoys. So let's run this script again. We're drawing out a hexagon, but as I said, it's extreme late binding. So if I make a change, right now the star is turning by 60, which is the external angle of the polygon. It's what you would walk out if you're walking out the polygon, and you take 5 steps, turn 60, 5 steps, turn 60, 5 steps, turn 60, and do that 6 times. You'd end up where you started. You'd have a hexagon. Now let me change it to 90. Who can tell me What's going to happen if I now turn by 90 instead of 60? Can somebody tell me what you'd see? Very good, very good. Now, this is a way young students can learn. Younger students wouldn't necessarily know that, even high school students. So I'm going to type in 90 and return. And you see now it's typing out a square. But that's what this extreme late binding is all about. I mean, we've just, everything is instant. You don't have to recompile. Let's say I wanted to change this to 360, and it's going to go crazy for a while, but that's okay, we'll get it back. And I'm going to instead divide by some number. I'm going to divide 360 by 3. What will I see now? Triangle. Very good. You guys are very, oops, I pressed the wrong key. You guys are very good. Now you see the triangle. Let me, if I want to get this little star, all I do is grab the object. Now I got the star. I've got it. It's immobilized. I've got it, so it can't run the program. But the minute I let go of it, it does the triangle. And then, of course, if they did 5, they'd see a pentagon. If they did 12, they'd see a dodecahedron, or what? Not it. Whatever 12 is, and so on. So it's a great learning tool because you can just explore and play with little things, change the script. There's lots of things you can do. So hopefully some of you were trying this while I was doing it. Were you able to try this and make it work while I was doing it? Yes or no? Yes? Okay, good, because this is sort of an introduction to using this. We're going to do a lot more later. Etoys engages learners. You see some pictures here of students using Etoys. You can tell that they're very actively engaged in working with Etoys. These are 10-year-olds, but your high school students would be engaged. I'm 68, and I'm engaged like that too, and I'm using Etoys. So as far as I'm concerned, it works for all ages. Well, one thing car, because students love cars, but I have this bee with a red nose. And a problem? Yeah. Okay. Students often are engaged by playing with cars. They draw a car, and then they're asked to put a sensor on the car and follow a track. Well, I have a bee with a red nose instead for a sensor. And this script says if the bee's red nose, that's the same color red, sees this gray color, it's going to turn 3 degrees clockwise. So it's going to turn back towards the blue strip it's trying to follow. If, on the other hand, it sees yellow, it's in here, it'll turn counterclockwise back towards the strip. So let's see what happens when I run the script. So see, if the bee tilts up, it turns back. As he tilts down, he turns back the other way. He keeps following the blue path. Now, there are problems with this, and that's where students can learn. Let's say I change this. I want the bee to go faster, so I change this to 30. Well, the bee's off the track because it was too fast for the bee. So then the question would be, how you engage a student is, well, right, have more sensors. Try something different. See if you can make the bee follow the path and go faster. That would be a good challenge for the students, and that would really engage them. They would try all kinds of things, and they usually succeed. So this really gets students interested in doing things because they're, as I said, when they make a change, it's instant. And they get feedback instantly, and they learn quickly, more quickly than if you don't get it instantly. And interpreted language is very useful that way. It makes learners thinking visible. I like to say, somebody in Japan made up that phrase, but, and this is a student who is having an aha moment. But let's say a student looked at this bee and said, I would like to be able to steer this bee. You know, students come up with anything, and that's certainly something a student might come up with. I'd like to be able to steer this bee. So let's see how we create what's called a viewer for the bee. I'm going to hold down, and you should try this yourself. I'm going to hold down, in my case, the command key. I've got a Mac. In your case, if you have a PC, the Alt key, and I'm going to bring up this halo. Is everybody able to bring up a halo? Yes?
You guys pull up a halo?
No.
No, Randy.
Just rock
No.
You gotta put your cursor right on the bee and click and hold down the Alt key at the same time if you have a PC.
How do they get the bee?
the game.
So you must not have my presentation.
Oh, no, I don't. I'm just running Etoys.
You guys do. It's on your jump drive.
What do you have?
Oh.
They didn't load the presentation on their computers. They have them on their jump drive.
Oh, okay. Well, then just, okay, go, instead of a B, go to this box up at the top called Supplies. Click on it and pull out whatever you want, a rectangle, an ellipse, a star. I'll pull out an ellipse and bring it onto the world. This whole area where you're working is called the world. You able to do that? Okay, now instead of, you'll be using the ellipse, hold the cursor on the ellipse or whatever you picked, hold down the Alt key and click and you should get this halo. Is that, you're there now?
No.
Okay, now I'm gonna open a viewer, which is this light blue or turquoise colored object on the left. Maybe Control. I thought it was Alt on the PC, but on the Mac it's Control. Or Command, sorry, on the Mac it's Command.
So Randy, it's what on the PC?
It should be Alt. The Alt,
On the Mac?
LT key.
And on the Mac?
At the same time.
You're supposed to get a B? Mine is not the command key. I get nothing with command. I just get a star.
What is the command key supposed to do?
They all have the halo now.
Okay, and so click on the open the viewer for me and you should see something like this. Yours will say ellipse instead of B or whatever you chose as your object. And starting to create a program is easy. I'm just going to pull out the forward by command and it automatically puts it in what's called a scripter for me. So now I have a program that'll make the B go forward. If I click the exclamation mark, it'll go 5 steps at a time. I can either click it from the script in the viewer, or I can click it on the scripter, which is on my world, or I can even do it from B forward. Anytime you click the exclamation mark, it'll make that happen one at a time. Let me also pull out a turn by, and when you see the green in the scripter, that means it's ready to accept the tile. You just let it go. Now I've got the B going forward and turning by, and so what the B is doing, it's going in a circle.
Hey Randy,
Yeah.
can we hold on just a minute? Because I got 2 people who can't get the halo thing, and then they're trying to help each other, and they're missing what you're saying.
Sure.
One individual has a PC. He brought down a circle, but when he clicks on the Alt button, nothing happens.
Well, you have to hold the Alt key and click with your mouse at the same time. Click. Hold, the cursor has to be on the ellipse. You have to click. You have to click your left key on your keyboard.
Okay, got it now.
Okay.
All right. Before I come
Gotta
on,
do 2.
anybody else need to get?
I just need to know what
You
we're
have to
doing.
do 2 things at once. Hold down the Alt key and click.
I have no idea what my objective is.
Okay. Does everybody have a halo?
Yeah, but I have no idea what my objective is.
Okay. He has his halo, but now because he was hindered with that, he doesn't know what the next step is. So.
Okay, so let me close this script.
The whole thing.
I want to create a script. This time it's going to be a new one for me, but that's okay. I go to the basic category where it says B forward by, and I click on that tile and drag it out. So I click and drag it out and onto the world and let it go, and it goes into what's called a scripter.
can you do us a favor and just open up a new project? Because we don't have a B, we don't know where to get a B. All we have is a...
Just use an ellipse. Okay, I'll use an ellipse. Never mind.
Can you just get a clean screen and just start us from scratch?
Should we be on make a project? Is that
That's
where
the
we
first thing
start?
is-
Like a project.
Make a project.
The little
Okay.
box.
What
What is the overall goal for them to do? Are they creating?
The overall goal for them is to learn something about Etoys so that when I'm not there, they can use it, and to learn what Etoys is at the same time.
Okay, but
It's a tutorial, right?
what are they doing? They want to know what the objective is like right now. Like what specifically?
We're going to write a little script.
Okay, so you guys are writing a script, and he's giving you.
Okay, let me start again at the beginning of this slide. Let's say you have a child, and a child has an ellipse. In this case, since nobody has a B, child has an ellipse. Oops. So a child pulls out an ellipse and says, "I would like to write a script so that I can steer this ellipse with a steering wheel." In fact, let's do this differently. Let's do what they normally do. I wasn't going to do this, but we'll see how this goes. What normally children like to do is have a car. So let's draw a car. So does everybody see my cursor where it says make a painting? No.
I didn't do anything.
Yes or no?
Does everybody see the painting icon?
Yes.
Yes,
Okay,
Randy.
click on that and you'll see an area where you can make a painting. There's a screen over the area so you can't do anything but paint right now. I'm going to paint a crude car. You can also try to paint a crude car. My car is going to be very crude. I'm going to put wheels on it. This is going to be the body. I'm going to put different colored wheels on it.
Is my mouse around?
So now I have, pretty soon I'm going to have a car. I got to get this icon out of the way. I'm going to have a car. You don't have to make it perfect. Important thing is to have a sensor on it. I'm going to make a yellow sensor. It doesn't matter what color it is. I'm going to put it right on the front, on the nose of the car.
Okay, wait.
So you don't have to have wheels, but just so you have a blob with another color sensor on it.
Randy, what's a sensor and how do you make one? Is one of the
A
questions.
sensor is, this is just going to be a color. It's just a circle that I put on there. I've got the circle object selected right here for my drawing. So this is just a yellow circle I put. It's going to become a sensor. It's not anything special. It's just a drawing.
The size does not matter for the sensor?
Well, it's nice to make it kind of small like mine, but no, it doesn't matter a lot.
Okay.
Well, actually, in this case, we don't actually need the sensor. I'm not going to go that far, actually. But once you get the automobile or whatever you want to call it, you click on the keep key, right where I have my cursor. You click on it, and the drawing tool disappears, and you have your object. Now, this is an object like any other object. If I hold down my command key and click on it, I get a car. I get a halo. And I'm going to now choose to open a viewer.
So hit the blue with the eyeball, open a viewer.
Right. On the
I'm checking
Now-
on him as you give him a command. I'm checking with him so that we don't get behind. Go ahead, Randy.
Okay, now I'm going to make a script, so I'm going to pull out. I click and drag the sketch forward by, or some people just call that dragging. But if you hold the mouse down on the sketch forward by and drag it out,
Give it a pink.
you have it pop into what's called the scripter. This object here, this whole object is called a scripter. This is one tile. I put the tile onto the script. I've got a script, but when I turn green in the scripter, it's ready to accept the tile again. So all it'll do now is go forward.
Okay, the script is the programming instruction for that object to do.
Yeah, go forward. The nice thing about the tiles is very descriptive. Forward by is pretty clear. It goes forward in the forward direction of the automobile. Then I want to turn it by a certain amount. And so I just add that tile. It turns green when it's ready. I just add it. And now it's going to go in a circle. Now, if I click on the clock in the scripter, it'll run continuously. If I stop, click it again, it'll stop. If I click the exclamation mark, it goes one at a time. Now, let's get back to what the child is imagining. The child says, I would like to steer this car. So let's draw a steering wheel. So we're going to go back now to the drawing tool. This time I'm going to draw a steering wheel. It's going to be crude. I'm just going to draw a circle for my steering wheel. I'm not very good at drawing circles freehand. And then I'm going to put in some bars that you might see in a steering wheel. And one bar so they know that that's straight up. It's not that important. So just draw something you want to call a steering wheel. It doesn't matter. And I'm going to keep that. Now, when I, yes.
One of the questions was, okay, they did the clock and it went in a circle like the hands of a clock. If they wanted to then make it go forward again, what do they need to click to make it go forward again?
Oh, it is going forward right now. It's going forward and turning. But if they want it just to go forward, just pull the turn by out of the script and it goes forward only. Or if they want it just to turn around and spin around like that, like.
So they need to keep recycling those scripting tiles in order to keep getting the command to go.
Well, if they want it to only go forward, yeah. It depends on what you want. Right now, I'm just having it go forward and turning just because it keeps in the same place. The goal here now is to actually steer this car with the steering wheel, not have it go turning around by this tile turn by, but actually to steer it by a steering wheel. And this is where a student can get a concept of a variable or a symbol, something standing for something, particularly younger children. This is designed for 10-year-olds, but it certainly doesn't hurt in high school for students to reinforce their understanding of what a symbol is. So I now have what I'm going to call a steering wheel. But another thing you can do when you click on and get the halo is if you click on the name sketch, I'm going to call that steer. So it makes more sense. Now I've just called it steer. You don't have to do that, but just so you know, you can rename it. You can also rename it up here. If I wanted to click up here, I could rename it at the top of its viewer. So what I want to do now is this is the steering wheel's heading. That's what this tile that I'm on stands for. I'm in the basic category. It says steer's heading. So that stands for the steer's heading, which is 0 right now, which is straight up. Straight up is 0. The steering wheel is pointing straight up now. So I'm going to have, instead of it turn by 5, it's going to turn by the steer's heading. So I grab not the whole thing. If you go over here, you see a red border around it. That's going to allow me to change the steer's heading in a program. I don't want that. I just want the steer's heading itself, the object, the name of the steer, its heading. And I just grabbed this one little tile, and when I bring it over by the 5, which is the turn by, you see the green box. I let it go, and now it's going by the steer's heading instead. So we've made a symbol. It's no longer turning 5. It's turning by the steer's heading, which is 0, so it's not turning at all. Now if I grab the steering wheel and start moving it around, you'll notice that as I change the steer's heading, I can actually steer this object. Let me show you what the steer's heading actually is. If I go to this tile on the left of the steer's heading, I have a choice for having a watcher. I always like the detailed watcher. I bring it out. That shows me the steer's heading right now is 0, straight up, and that's why it's going straight. And then as I grab the steering wheel, you can see the steer's heading is going to positive, so it's turning clockwise. Now it's going negative, it's turning counterclockwise, and so on. So this way a child can get a view of what a symbol is, and they can play and they can try things, and children actually do these kinds of things. That's why I use this example. So that's just, you're going to get more practice later. If you didn't catch all this, we're going to get more practice in a minute. But I just said, want you at the same time to get some idea what Etoys is and get a little practice. So you're not totally without help, but there's a lot of help here, and I'll show you that in a moment. Just some quick stuff about Etoys so you get some idea. Alan Kay was the person who created the environment called Squeak. He wrote Small Talk in the late 60s, and then he developed Etoys as a special part of Squeak for 10-year-olds. It was designed as a thinking tool, as I said. It's a dynamic extension of pen and paper, and it's accessible to all ages. And as I said, I like it. I'm 66, so it's a fun environment. Authoring is always on, which means you can always change things. As I showed you, the minute you make a change, it's there. It isn't like some tools. Take Flash. If you want to create a Flash simulation, you have to go to the authoring tool, which costs money, and you have to do the authoring, and you don't really see what's happening as well until you've got it all done. Here, you're authoring while you're watching it. It's not a production tool. It doesn't have a lot of fancy things like, say, Photoshop, where there's all kinds of pictures and so on, or cool pic, or whatever the picture tool they use for kids, where there's all kinds of pictures to bring in. It's just bare bones, mainly to not distract students so they can really be creative. It makes simple ideas simple and allows for complex ideas to be possible. And maybe I'll be able to show you that later if there's time. By the way, everything here is an object. You look at the trash can and you think Microsoft, well, you can't deal with the trash can. I can deal with the trash can. I can make the trash can go forward. I can make the trash can turn. I can make the trash can do anything I want. Well, not anything I want, anything within the limit of the possibilities. So, by the way, here's the different categories for things you can do. So there are probably 150 different things different tiles you can choose for your scripting. So you put those all together and you can make a lot of interesting things happen. So that's Alan Kay's view. Jerome Bruner, I'm sure you're all familiar with Jerome Bruner. What Jerome said, no, I'm getting feedback, I see. It's meant to disturb people. It's meant to make them think. It's figuring out how you use what you already know in order to get beyond what you already think. He was one of the original supporters of Etoys, and he and Alan Kay had a lot of talks, and he's a strong proponent of Etoys. So if you're a Bruner fan, definitely he's behind this. Here's Seymour Papert. Are you getting the feedback or just me?
Just you.
Yes or no?
No, we're not getting any.
Okay, that's good. That's good. Then that's fine. I don't mind it. Seymour Papert worked with Piaget. Piaget needed somebody in mathematics with a mathematics background, and that was Seymour Papert. You can see his quote, "You can't teach children by telling them." And that's what this is all about. They have to do something. And he's big on mathematics. Mathematics is not marks on a page. It's what those marks represent. So it isn't drill and kill. It's really what's behind. It's the idea of addition, not being able to do addition that's really important. And again, he's on the board for Etoys, strong proponent of Etoys. You probably realize that he developed Logo. Some people describe Etoys as Logo on steroids. Etoys is international. Uruguay has given out 300,000 exo computers. You see one right here. If you haven't seen one before, they're the supposedly $100 laptops that ended up costing $200. But they bought 300,000 of them, and they've distributed them to all the children, most of the children in Uruguay. Some children in high school still don't have them. And there are a lot of other countries using Etoys. It's a worldwide cooperation to improve education. So it's not just a US based operation, although it was started by Ellen Kay, who is American. Okay, now what I want you to do, and we're going to go to the makeup project. You can't do it from here, but you don't have my presentation anyway. We're going to try Etoys. There are tutorials and demos, and we're going to look at one of the tutorials and actually have you do it. There's the makeup project. When you click that, you get a blank screen. You're all ready to go. Then there's a gallery of projects, so you can see other projects and learn from them. And then there's very important help. And we're going to look at all those things. So what I want you to do is get a clear screen, but I'm going to click back until I see the Etoys start screen. So you should be right here. And if you're not there, just click this back button until you get there. Previous project. Is everybody there?
Okay, ask him. Hold on.
I got it. Click the circle, which is, okay.
If you,
Don't click anything in here yet. I don't want you to go to the, I just want you to be at this main screen.
How do you
no,
get there?
just, we need to have him pause for a
Pause
minute
it.
so we all get there.
You get the back button.
Back?
Back button.
Where, this? This?
So just go,
Pause in between
there you go.
commands so that they can catch up with you.
I'm waiting.
How do you get rid of this one? How do you get rid of the car? How do you get rid of
Let
the?
me know when you've got this.
Try,
How do you get rid of the paintbrush?
If you don't draw, if you don't.
Oh, you gotta click keep if you're in the paint
What if you don't
tool
keep
or toss.
it? Okay, got it.
She's good. Okay, is everybody else good? Okay, Randy.
So now, here are the things that I talked about. Let's do tutorials and demos first. So go to the cloud. You should see the border highlighted and click on it once, and you should go to the tutorials and demos. Everybody there?
All right, yes.
Now click on the one at the bottom, the Etoys challenge game. And I'm going to have you do this. So I've shown you enough, so you should be able to do this. So is everybody here?
Yes.
Click on the arrow. Okay, here's the goal for the first screen. This is actually a book, but you can't see the controls. There are several pages in this book. This is the first page. So for this first page, the goal, we want to send the car to the goal. And here's our scripter. We want to take one of these tiles and put it into the scripter to achieve our goal. So what I want you to do is pick the one you think should go in there and put it in there, and then start running the script and see if you've achieved your goal.
How do you run the script?
Hold the tiles over.
You just put your cursor, let's say I want a car turned by, I put my cursor on it, I click, hold down the mouse, the left mouse, the left key, and then I drag. So it's basically a click and drag. You can drag it anywhere, you can put it in here.
That's positive, that's where I started.
Oh, you weren't supposed to.
When it turns green, it's ready to accept it.
It said turn car by 5. I
I
did
know,
that.
but you weren't supposed, no. Your goal was to drag, to get this car.
The goal is to have this car,
These three commands.
this red car, go into this hole once you run the script.
Bring that over.
So the
Script to send
a
the
question.
car to the goal.
can you hear me okay?
Yes.
Makes sense.
So when it says car turned by 5, that 5 is a radius. It's not a.
What's the clock thing you were talking about?
Turn 5 clockwise.
5 degrees. It is degrees. Okay.
It is degrees. This would turn 5 degrees counterclockwise, and this would go forward by 10. And when you run the script, you keep doing it over and over and over and over. So it'll go forward by 10, 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 until you stop it. Or it'll turn by 5, turn by 5, turn by 5 until you stop it. Or like this, it will go forward by 10, turn by 5, 10, turn by 5, forward by 10, turn by 5 until you stop it. So your idea, what you need to do is put in right tile, run the script, and if you hit the goal, you'll get an arrow at the right, a yellow arrow pointing to the right in this area. Has anybody got it yet?
Yes.
Yeah.
They said yes.
All of them, or should we wait?
Everybody had an opportunity to.
Well, actually, what you can sort of do this independently. Once you've got it, let me just do this one so you see what happens. I start the script, and it's going to achieve the goal. It's going to hit the goal. Once it hits the goal, there's a yellow arrow over here. You go to the next one.
Can we change
Now the car is pointed up. You want to achieve the goal.
It was a weird species.
You want the car to go into the goal by writing your script. And so if some of you get ahead of us, you can just click the right arrow and go to the next one, and the next one. I think there are 5 of these, 6, probably 6.
Are you good?
Oh, oops, I did the wrong thing. Yeah, well, no, turn. I did it. Turn.
Good? Yep. You guys good?
No.
No.
All right. What do you need help with?
Yay.
You need to get an educator on board so that you're right.
Are most people working on step 2?
I'm on step 3.
Good.
Not sure you can turn it, so how do you turn it?
Yeah, right here. Turn car by 5 degrees, so it'll turn 5 degrees, and you keep on adding more of those scripts to make it turn
You
all
can't
the way.
change
You have to go, but it's,
How many have achieved step 2?
Yes.
can't understand you.
How many have made step 2 work? How many have got to the goal in step 2?
Used to it. You won't walk away.
Oh, maybe.
You know,
I've got it.
Good.
you're good.
So not
Maybe you can show somebody else or help somebody else.
the box over to the
Anybody
left
need
so that
help?
you can manipulate. And then manipulate it to positive or negative, change them up or down to make the car go to the goal. The goal is a green box.
Right, and then after you put
No, I'm just telling you that's what the instructions need to be.
Oh, I get it.
Complete the script to send the car to the goal. Make the car go there. But I don't know, that's just me.
Sorry.
So I got it.
Okay,
That's
you guys good? You to the goal? You definitely will walk away saving efficient. You're getting the best time to do it.
I need a copy. Does anybody know how to copy it?
You shouldn't have to copy it now because it does it continuously. Oh, that didn't work.
Has everybody made it to their goal?
Let me show you what will work. If I go forward by 10, and then I also turn by 5,
Oh,
that will allow the car to go around in a semicircle
Then what?
let's try that.
and achieve the goal.
Oh, made it to the next one.
So if you didn't do that one, there are plenty of others. Then you can go on to step 3. And it gets more and more complicated each time.
Now, were you saying, Linda, that you're not supposed to change the little numbers?
Yeah, you don't have to for these. I mean, you could in the real life, but these are tutorials that have been set up so that you don't need to change the numbers.
Now this one I see a second way to do it if you modify one of the tiles, but
Oh, see, that's what I'm doing every time.
there are often, usually several ways to achieve a goal. So
Send the car to the goal without modifying the tiles.
of course,
Okay, mine has an error.
here would be one way to achieve the goal, but that isn't fair. You can just grab the car and put it right in the goal, but that's not the objective.
Mine says I need to abandon an error has occurred.
User error.
It says you should probably just hit abandon sorry.
I think another couple minutes, and then I think we'll go on to something else. Actually, you can go back and work on this and complete it, and it will help you learn about scripting. So I think there are 3 or 4 more steps. I mean, everybody got the first one, so that's a good start.
Yes.
So what we're going to do now is look at some of the other things. If you click this previous button, the left arrow on the top again, you can get back to the tutorials and demos. There's a tutorial here where you learn about using halos. So you could do that tutorial if you want more information on using halos. This is just a demo that shows what you can do with Etoys. I'll let you do those things on your own. So we're going to go back one more. As I said, make project gives you a blank screen. You're all set to go. We won't do that right now. Gallery of projects, all kinds of things to look at, including the challenge we just did, the castle where you learn about halos, and some more complicated ones. Here's one where there's something called Kadama, which is more advanced, but you could have your student learn about, and it's an infection simulation. And when I start the simulation, there's one person that's red that's infected, and you see very quickly the whole village gets infected. But you can change a lot of parameters and try things, Kadama. So there are a bunch of different projects to learn from. Now, here's perhaps the most important thing, and that is there's help. So if you go and click the question mark in the upper left, there are quick guides which you can access instantly. If you wanted to know about the paint tool, you could click on that, and you see there are several different things. Let's say you wanted to know how to make an ellipse. You could click on the ellipse tool, and there are 4 pages here on how to use the ellipse tool with diagrams so you can see what's being done. And then if you want to go back to some other kind of help, you can jump to any of the different selections, any of the different sub-selections, or what we're going to call them. So you can choose whatever you want just clicking on the jump to. If I want to know about the menu, want to know about normal picking, I just click that. There'd be a little help section of 4 different, sort of a book with 4 different pages. It tells you about that problem. If you click the question mark, again, the help goes away, gets out of your way. So you got a lot of help and tools there. Now I want to go back to my project. I want to time to show you a few more things that are important. So you got a little bit of time to play with Etoys. If when I finish, there's a few minutes, you can ask questions about Etoys, or we can do more, but let me just finish these slides, which you don't have. One of the reasons I was asked to make this presentation is I wrote a chapter in a Flexbook. CK12 writes a lot of different textbooks. They're all online. And this chapter was about the NASA launch abort system. And it allowed students using Etoys to experiment with motion, particularly of a rocket, analyze the motion, explore the motion, and then simulate the motion. So I'm going to leave Etoys for a minute and show you that book. Since you have my presentation, you can get all these URLs. They're in the presentation. that the Flexbook is here. There's a CK12 organization, and that's the whole organization. Let me find my book down here. It's 21st Century Physics over here. And I'll go down to my chapter on the launch abort system. I just want to show you what's here. If you're teaching physics, some of you are maybe perhaps, and you want to do some modeling and simulation, you might want to start from here. Basically, and this is all online and it's free. There's an introduction to the launch abort system. And basically the idea of this is to teach students about motion. And so there are all these definitions, the standard definitions you would be using when you're talking about motion, velocity, acceleration, and so on. This is if you're teaching that, you don't have to worry if you aren't. There are other things. But when they go through all these, I put all this information in there so they have it. But the important thing is that they model what's happening, and they start out with the simplest model and move towards the more complex model, and they use Etoys all the way. They add they start out with a simple model with no air resistance, constant acceleration. Then they add air resistance, and then they make a more realistic rocket, which actually is closer to the NASA rocket, but the actual NASA rocket is proprietary, so they can't simulate the actual NASA rocket because they don't know all the parameters, but this is close to it. And then a student in the summer created a simulation of the launch abort system in two-dimensional, in 2D. Everything else was 1D. And all this is here. So I was going to show you the, this is a link to my page, which you can get by going to that book. There's two things I did. I did modeling and simulation with modeling a laser and the intensity of the laser changing as it went through clouds and aerosols. But the one we're talking about is the abort system. This student, Jeffrey Conrad Royo, created this simulation. Let's see. Let's see. Oh, this was set only to, okay. I'm going to save the file. And then I'm going to open and run it for you to show you what he did.
Hey, Randy.
You don't have to, yes.
You're breaking up really bad. Can we end this call and call you right back?
Sure.
Because the wireless isn't picking up the way it should be.
Okay.
I'll call you right back.
All right.
I don't know if it's his headset.
Sounds like that whistling.
Yeah.
Randy.
Hello? Is that better?
Yeah.
Okay. I'm going to see if I can find this simulation in my download. Yeah, here it is. Okay. I'm going to open the simulation. Oh, that's going to close my, that's okay. I'll open my other thing again. So this is the simulation the student did.
Randy, can you share your screen again?
Oh, yeah. Let's see, where are we here? Sorry. It would help. Got it now?
Loading. Hold on 1 second.
Yes.
There we go.
Okay. This is the simulation the student did for his summer project. Let me make it full screen. I can't remember the exact proper number for this, but students would have to explore. Let's just try that and launch and see what happens. So this is the NASA rocket launching from the launch pad, and if something goes wrong, it has to abort, and it has to hit this area right here so that it lands properly at the right place so they can collect the astronauts because something went wrong, and we'll see if it hits that area. So he did this simulation. It doesn't include wind, but it includes air drag. And okay, they hit the area, and now he put this nice simulation in of the parachute. So you can see what you can do if you want to make things a little bit fancier. So let's get back to mine. I got to open mine again, and we'll continue on. I have a lot of projects. Everything in Etoys is called a project, and it ends with a .pr. So it helps if I could spell. Okay. So that file I sent you has a .pr on the end. That means it's an Etoys project, and you need Etoys to open it. Why is my book suddenly, oops. Oh, there we go. Something, oh, the book got small. How did that happen? Well, let's just, you can see it, so that's an important thing. Okay, next thing I wanted you to know about is, and this is misspelled, is that you should be able, you can go to squeakland.org for a lot of help. And I'm going to minimize this and go back to Squeakland on my Firefox. Come on, Firefox. Oh, Firefox, where'd it go? Oh, it's open one page. Something happened to Firefox. Well, if that isn't happy, then we'll go to Opera. I'm going to close Opera and go back to Firefox. I have everything. What happened to Firefox? Well, we'll go back to Opera then. I don't know why Firefox decided to do that to me. I'm going to just type in this. You just have to type squeakland.org. And I've done that a lot, so there it appears. I just wanted to show you what's available on squeakland.org once it loads. First of all, there's an About section where you can learn about, you can get an introduction, why Etoys, why you want to use Etoys, the people behind it, and donors. There are tutorials on here. The quick guides, which I showed you, are actually here. There's some interactive demos. This is basically what you saw already. It's on Etoys itself, so it isn't that helpful. A lot of resources, though, that are helpful. The whole community, you can see the community all over the world that's working all these links. Etoys Illinois is very important with a lot of projects you can see. I'm not going to go there now, but they have thousands of projects that you can look at and learn from. And there are articles, particularly by Alan Kay, about how children learn and so on. They're very useful. There are some books you can either get online or purchase. There's a little bit of audio-visual where you can see students actually using Etoys. You can look at any one of these videos. Another important thing is there's a showcase. Showcase has projects that people have uploaded. There should be one on here that I just loaded the other night. But when your students create a project, here's the point. When your students create a project, they can upload it onto the Squeakland website, and other students can see it. They can show off their work, whatever. For many people, there are right now 300 projects on there. There should be one I loaded last night coming up now because I did it by date. So you see there are several, well, see a lot of people have done it since me. Let's see. There's one. I loaded this on the 20th, And then since then, there have been a couple uploads, probably from Uruguay or Argentina. A lot of South Americans are doing things, so some of these are in Spanish. Etoys is multilingual. So let me hide that. Let me go back here. Okay. So there's squeakland.org. The last thing is I've created a web page. Since I had everything in Firefox, I'll have to go back to, so again, this link is in the project I sent you. I have to go back to Opera to do this. I don't know why Opera is choosing not to work now. I wonder what happened. Come on, Opera. Okay, I'm gonna try. It looks like I'm back at Firefox now. I've never had this happen with my browsers. It's probably this tab. I'm gonna close this tab. I always worry about closing tabs. Let's see, I'm connected to the internet, so I don't quite understand why I'm having all this trouble. Well, you're just gonna have to look at this. I was hoping to have it open. You're gonna have to look at this, but I have several things to start with that I made. I made some simulations for you to try that you can modify and improve. There are simulations you could use, simulations you could modify, lots of different things you could do. But let's stop this right now. For some reason, we're having trouble. So let's get back to this. So there are projects you can build on, projects you can learn from, modify, and use. Now there's just a few minutes left. Again, why would you use Etoys? As I said, it's free and open source. It's easy to get started because of the graphical tile programming, but there's room for growth because students can learn Smalltalk and they can do very advanced things, and they can actually change Squeak and they can change Etoys if they get that advanced. It's a nice environment for simulations because it's object oriented. It's like an actor on the stage. Each one of those things is an object. Everything here is an object, and they can manipulate those objects and simulate things. So it's a great creative opportunity for students. What would you do in the classroom? Show your students Etoys, let them play with it, and let them explore projects. That's how they can learn. And they can get many projects at squeakland.org at the showcase. They can also look at the resources at squeakland.org and go to all these other sites like Etoys Illinois. They can find all kinds of projects, and my webpage, which for some reason I couldn't open. And you want to have your student then generate ideas for simple models and simulations. That's the whole point of this program, is for students to learn by simulating. They learn a lot more by simulating than if they play with simulations. So if they create them themselves, they're better off. So they want to generate simple ideas and then try to implement them in Etoys. And the last and probably most important thing is don't worry if your students learn more than you do. That happens all the time. I mentored a student in Argentina in the Google Summer code, and he knows 1,000 times more than I know about Etoys and about programming and small talk, and that's fine with me. Even if a high school, you got to realize your students are going to learn more than you. That happens all the time, and don't worry about it. So I guess we're out of time, unfortunately, because the web page is not loading, but I hope you got some idea of playing with it. If there is more time, I'm certainly willing to answer any questions you have.
I can give you a few minutes time for that. Do you guys have any questions for Randy?
I'd like to see how it spends more time with this.
Oh, you just want to play with it. I think they're kind of just wanting to play with it right now, and then I've given them your contact information, Randy. So do you mind if they contact you on a individual basis, maybe in the evening or on the weekend or something? You guys can set up a time to connect.
And my email information is on the web page. I think what happened here is that this web page is at Christopher Newport University, and they're doing something with their server. I thought they were going to do it Friday, but it looks like they might be doing it today. That might be why I can't. So you might not be able to find that web page today. I'm not sure.
I do have one teacher who had a question. What was your question?
Are there lesson plans focused more toward the secondary, high school level, or I guess they can build from this type as well?
Her question was, do they have lesson plans that are built for the secondary level, or can they be built upon with that, or are they only for that level?
There are no specific lesson plans. I mean, what I put on the web page is some
Project ideas.
Etoys like for instance, there's a project that simulates an epidemic, different from the one I showed you, simpler. And students could take that and modify it a lot and learn from it and build on it. And there are some, well, I can show you one, it can't be online, but let me open one that I did. And show you what I mean, so you get some idea. It's not really a lesson plan, but you'll find this on my webpage, Starsick. It's, as I said, a model of an epidemic. And let me make it full screen. What there's a guide. So the guide here just tells you things you can do and challenges. It's very short. Sometimes my guides are many pages. Sometimes my guides are, typo. Sometimes my guides are books with 10 pages. Sometimes they're just one page like this. And then this particular one has stars. So you pull a star out, and I can keep getting more and more stars to populate it. You can create your own flaps that are what are called parts bins, and these have stars with programs in them ready to go when you pull them out. That's the way I created it. But there's a lot here for students to do. The way I simulated this epidemic is very crude. There's a little script here that shows it. They can do a lot more. So basically, it's things like that with guides. I have more complex things that I've written for mainly for elementary school, but could be used in high school, and they do have step-by-step guides with many pages and be more like a lesson plan. But for the high school, not really lesson plans.
All right.
I think that's what you're supposed to create, actually, but I'm not clear on that.
All right. Well, we have to run, Randy, because we have our next activity coming up. But
Sure.
They have your contact information, and they can contact you and send you an email, and you guys can work out a time to further explore this.
Yeah, and we can actually Skype if you want, which is going to be one-on-one, which would be a better way to learn.
Okay? All right. Well, thank you very much.
You're welcome.
Thank you.
Have a good day.
Have a good day.
Bye.
Bye.